Hello, here's a short video on titrations and how to do titration calculations. A titration is a form of volumetric analysis. So we use volumes to analyse usually the concentration of a particular solution. There are two main pieces of glassware that you use. One is a burette, which is a long tube with calibrations on it, and these calibrations are usually 0.1 of a mil. It has a tap at the bottom, and you can either run the solution in quite fast or just drop by drop. A drop is about 0.02 of a milliliter. And then there's a conical flask that it goes into, and we use a pipette to measure out a fixed volume of solution that goes into the conical flask. The volume that we measure out with the pipette is called the aliquot, and the volume that we add with the burette measuring is called the titer. Usually we do three runs, and our titers need to be concordant or grouped together close enough so that they're within 0.1 of a milliliter, but we'll teach you more about that when we do the practical side of it in the laboratory. So the calculations that I do are quite straightforward. They are in three separate steps. Step one, you will be given a solution of known concentration called a standard. So step one is to work out the number of moles of the known solution. And with solutions, the number of moles is the concentration times the volume. And of course, our volumes are always in litres. Step two is to calculate the number of moles of unknown that have reacted in the conical flask from the number of moles of the known solution. And to do this, we use the stoichiometry of a balanced equation. And the third step is now to work out the solution or the concentration of the unknown solution, and that is simply the number of moles of the unknown solution, which we get from the stoichiometry, and the volume of the unknown, which we get because we've measured it either with the pipette or with the burette in the titer, and then we can calculate. So let's have a look at a particular problem. Let's say that we have 14.5 milliliters of hydrochloric acid, and this is needed to completely neutralize ten milliliters of 0.11 mole per litre sodium hydroxide. So what have we got? What we've got is that we've got 10 milliliters of sodium hydroxide in the conical flask. How do I know it's in the conical flask? Because it's an accurate measurement of 10 milliliters, so I must have measured with a pipette, and I also know that the concentration is 0.11 mole per litre. This is my known solution because I know the concentration. So here's the concentration of the known. This is the volume of the known, 10 millilitres. So here, what I'm doing is I'm adding HCl, and I add 14.5 millilitres of HCl. So let's have a look at the calculation. Step 1 is to work out the number of moles of the known, or the sodium hydroxide. This is the concentration times the volume. I'm told that the concentration is 0.11. The volume is 0.010 litres. So it's very easy to change millilitres into litres. I originally had 10 millilitres, 1, 2, 3, shift the decimal point 3 places, and you convert it into litres. So the number of moles of sodium hydroxide is 0.0011. Step 2, the balanced equation. HCl plus NaOH gives me sodium chloride and water. Generally, the equation will be given to you, particularly if it's an assessment, then that'll be given to you. So this is a 1-to-1, and most of them will be 1-to-1, where 1 mole of HCl reacts with 1 mole of sodium hydroxide. In other words, if I have X moles of HCl, the same number of moles of sodium hydroxide react. In other words, the number of moles of HCl and the number of moles of sodium hydroxide are the same to completely react. So the number of moles of HCl is going to be equal to the number of moles of sodium hydroxide. We just worked that out here. So this will be 0.0011. The third step is to calculate the concentration of the HCl, which is the number of moles over the volume. The number of moles I had just worked out here is 0.0011. The volume is 14.5 millilitres, but of course I need to change that into litres, so it's going to be 0.145. I'm going to poke those numbers into my calculator. 0.0011 divided by 0.0145, and that gives me 0.07586. I'm going to round to 3 significant figures, so 0.0759, and the unit is mole per litre. So there we had it, very simple, very easy to do. Here's another slightly more difficult problem, and this is out of your ESA textbook, page 52, question 6. To summarise, you're told that you've got 25 millilitres of sulfuric acid, and this was titrated with 0.082 mole per litre sodium hydroxide. The end point, it says, was at 22.5 millilitres. End point is when you end the practical titration, which is when you see a good firm colour change. The end point is when the acid should be completely neutralised or completely reacted with the base. So what do we have to find out? We're asked to calculate the concentration of the sulfuric acid. So this is the concentration of the unknown that we want to know. This is the volume of the unknown. So the sodium hydroxide must be the known. So this is the known concentration, and this is the known volume. So step 1 is to calculate the number of moles of the known. This is the sodium hydroxide. So we are told that the number of moles is the concentration times the volume. We're told that the concentration is 0.0820. Don't need to worry about the 0 on the end. And the volume is 22.5. I'm going to shift the decimal point along three places to change it into litres. So I put that into my calculator, 0.082 times 0.0225, and that gives me 0.001845. Now I'm not going to change that into three significant figures. I'm simply going to leave the full numbers on my calculator screen so that I can continue calculating with that number. Step 2 is the number of moles of the sulfuric acid, and I need to work that out from the balanced equation. Sulfuric acid plus sodium hydroxide react together to give me sodium sulfate and water. Sodium is a +1 ion, sulfate is a -2, so I'm going to need 2 sodium ions to go with the sulfate. So I'm going to need 2 sodium hydroxides with the 1 sulfuric acid to give me the 2 sodiums. So that takes care of my sodiums and my sulfate. I'm now left with 2 hydroxides and 2 hydrogens. 1 hydrogen goes with 1 hydroxide to give me 1 water. So 2 hydrogens goes with the 2 hydroxides to give me the 2 waters. So my equation is balanced with 1 sulfuric acid with 2 sodium hydroxides. If I have X amount of sodium hydroxide, I have X over 2, half the amount of sulfuric acid. So my moles of sulfuric acid is going to be my moles of sodium hydroxide divided by 2. So it's this number here, 0.001845 divided by 2. The numbers are still on my calculator. Divide by 2 equals 0.009225. And the third step is to calculate the concentration of the sulfuric acid. Concentration is the number of moles over the volume. The number of moles I've just worked out is 0.00092225. Simply leave those on the screen. The volume I'm told is 25 millilitres or 0.025 litres. So I've left this number, the 0.00092225 on my screen. I divide that by 0.025, hit the equals button, and my answer is 0.0369 mole per litre. Easy peasy, lemon squeezy. Step 1, number of moles of the known solution. Step 2, from the balanced equation, you work out the number of moles of unknown that must have reacted with it. Step 3, the concentration is simply then the number of moles of the unknown, which we work out from here. The number of the volume of the unknown, which we're given, and it's a simple division to work out the concentration. Simple as that. 3 steps. 1, moles of the known. 2, moles of the unknown from the balanced equation. 3, concentration of the unknown. Boom. Easy as.